in this lesson, we're going to look at Section A.2. This time we're looking at the metric system. And so if we look at the metric system, one thing that we find if we do an internet search is that it was developed sometime between the 17 and 1800s. And two of the key features are that it's universal. And another one is that it's very easy to convert, to go from one unit to another, real easy conversions. And so here's a chart that shows the conversions. And it says the basic unit of measurement in the metric system are meters, and that's talking about length, grams, when we're looking at mass or weight, and cubic meters for volume, which is capacity, but then liters for liquid volume. And for this chart, they gave us the unit of meter. So meter could be replaced with gram or liter. And notice it says, unlike our US where it might be 2 for 1 unit conversion, or 4 or 16 or 8, these are all base 10. So we're moving decimals or working with powers of 10. And so if you notice, the basic unit is in the middle, and that's why there's a 1 there. 1 meters our basic unit. And then we get smaller as we go up by powers of 10. So we have a decimeter being 1/10 of a meter, a centimeter being 1/100th of a meter, and a millimeter being 1/1000th of a meter. And then going the other way, getting bigger, we're multiplying by powers of 10. So a decameter has 10 meters, a hectometer is 100 meters, and a kilometer is, or kilometer, is 1,000 meters. And they give you a little mnemonic device to help you remember the prefixes of King Henry died by drinking chocolate milk. So your K is your biggest, kilometer. H is your hecto. The first D is deca. B is your base unit, so in this case meter, or it could be gram or liter. And then centi and milli. So, as I mentioned, we could use the same chart by using other units. And so let's make a chart using our gram. And again, you could do another one for liter as well. But we're going to use grams. And so for our first one here, let's do 1 milligram. And I'm just going to use the abbreviations for milligram, and that's the same as 1/1000, or as a decimal, 0.001 grams. And then we have our centigram, 1 cg. And so again, as a fraction, that's 1/100th, or as a decimal, 0.001. Or sorry, just 0.01 grams. And then we have our decigram. Notice there's 2 that begin with C. So decigram is a decimal, and decagram is bigger. So we have 1 dg for that, and it's 1/10. Or 0.1 gram. And then we have our basic unit, so 1 gram. So again, that's our base unit. And then we'll move on to getting bigger. So 1 decagram, instead of dg for both, we do dA as a prefix, and then G for gram, or L for liter, or M for meter, and that is 10 grams. Then we have 1 hectogram for 100 grams, and 1 kilogram for 1,000 grams. So notice when we go from one unit to the next, from the base going smaller, we're dividing by a 10 each time. Going larger, we're multiplying by 10 each time. So a decameter is larger than a decimeter. I already mentioned that, that's true. Decimeter has a decimal in it, it's smaller. 100 kilograms is equal to 1 gram, that's false. We just looked at that, it's the opposite. It's 1 kilogram is equal to 1,000 grams. So they put it in the wrong order. And 100 centimeters is equal to 1 meter. And that is true because we said that a centimeter was 1/100th of a meter, so it takes 100 of them to equal the whole meter. So when we're looking at converting, we are able to multiply or divide by powers of 10 or multiples of 10. So if you're going 1 unit smaller, you're going to divide by 10. If you're going 2 units smaller, you're going to divide by 100, and so on. And if you're looking at going a larger unit, you're going to divide by 10, or divide by 100, or divide by 1,000, and so on, depending on where you're going. And so one way to know how many times bigger or times smaller you're going is using a number line. It's very helpful. And so notice we have this number line with our meter in the middle, that's our units. And then here's our decimeter, centimeter, millimeter. So they're going smaller by units of 1 to the left, and we're getting bigger to the right. And so decameter, hectometer, kilometer. So here we have to think of place value. And so this would be like where our decimal point is. It would be after the 1. And so here is less than 1. Here is greater than 1. And so what we're going to do is look at how many times we have to move to get from the unit that they give us to the unit they want us to convert to. And so notice here, for their example, they're changing 13.5 meters to millimeters. So they write the number on the number line. I normally don't, but notice they put the decimal place right here above our units. And then going from meters to millimeters, we have to go to the right 3 times. And so they move the decimal 3 times to the right. And we had to fill in zeros to be able to do that, just like when we were working with our powers with our scientific notation. And so that helps us being able to use those number lines. And so here's your skills check to be able to do that. So for example, if you're looking at going from 3 meters to millimeters, wrong way. 3 meters would be here. And to millimeters, we're going 1, 2, 3 spaces to the right. So we would need 1, 2, 3 zeros, so it would equal 3,000 meters. And if we look all the way to the left and all the way to the right, there's only 6. 1, 2, 3, 4, 5, 6 places. So the furthest amount you can move a decimal left or right, according to our prefixes here, would be 6. So for example, if you're going from millimeters to kilometers or kilometers to millimeters, that would require 6 moves, either left or right, depending on which way you're going for your conversions. And then notice number 9, we have meters cubed. So remember, for cubic meters, it's 3-dimensional. And so to get rid of that and to get to decimeters cubed, you would have to get rid of the meters 3 times, because we would have meters times meters times meters. And so if we're looking at our unit conversions, remember with our unit fraction, we would need to get rid of those meters 3 times. So we're actually tripling the amount of moves we do, which they're showing by a power of 3. So from meters to decimeters, let's go back here. Let me erase this real quick. Ooh, that's not the eraser. There we go. So in that one, we want to go from meters to decimeters. So here's meters and here's decimeters. That's only one move. So since it's to the 3rd power, we need to triple that, or times 3. So we actually have to move the decimal 3 times instead of 1 to do that. And so we would have to add 3 zeros instead of just 1 0 to the right. So it would be 73,000 in order to do that. So that means that if it is meters squared to decimeters squared, the 2 means we would only double it or add the 2 zeros. Okay, so go ahead and do 7 and 8 and check your answers. And when you're ready, move on and we'll look at our story problems together. Okay, the first one we have is an Olympic-sized pool. It's 50 meters long and 25 meters wide and 3 meters deep, and it asks us how many liters of water the pool can hold. So first, to solve that problem, we're looking at the volume. We know volume is length times width times height. So we're multiplying our 50 times our 25 times our 3. And if we do that, we get 3,750 cubic meters. And then it says determine how many kiloliters that is. Well, if you're looking at your workbook on 614, it gives you a quick tip that 1 cubic meter is the same as 1 kiloliter. So we're just replacing that meters cubed with our kiloliters. And so that would be 3,750 kiloliters. And now we're going from kiloliters to liters. How many is that? Well, if we're looking at our number line, if we're imagining that kiloliters was out here, liters is in the middle, and there's 3 spaces to get there. So that means we have to move the 3 spaces to the right. Here's our decimal, so that means we're adding 3 zeros to it. 3750, and then we'll add 3 more zeros. And that's how many liters we have. 3,750,000 liters. For our other story problem we have, the average weight of a female Asian elephant is 2.71 metric tons. A metric ton is equal to 1,000 kilograms. Notice this isn't the US ton, T-O-N, and that was 2,000 pounds to 1 ton. So don't get mixed up with the wording here. They want us to determine the weight in kilograms. And so to do that, it says that a metric ton is equal to 1,000 kilograms. And so we will do 2.71 ton. And our unit conversion is 1 ton equals 1,000 kilograms. So using that unit fraction, we can see that we need to multiply the 2. And we get 2,710 when we move that decimal 3 spaces to the right, or multiply by 1,000. And so now we have it in kilograms. And now we want it in grams. So again, if you think of your number line, kilograms is all the way to the left, grams is in the middle. And so that's 3 spaces to the right. So 3710, and moving 1, 2, 3 more times will get us grams. and that is 3,710,000. But now we want to go to milligrams. So if we take our grams, again in the number line, grams is in the middle, milligrams is all the way to the right, which are 3 spaces later. So we have to add another 3 zeros or move our decimal. Oh, I see a mistake I made. I put 3 here instead of 2. Not sure why, I apologize that. And so we have 2710,000, again, and here's our decimal, so we're moving 3 spaces to the right by adding 3 more zeros, and now we have it in milligrams. So 2,710,000,000 milligrams, the average weight of a female Asian elephant. So hopefully that you've went through this, you feel that our metric system is easy to convert, but sometimes a story problem or something might trip you up. So again, still don't hesitate to send me email, screenshot that question and send it to me if you need help with your homework. Otherwise, I'll see you next time. We only have one more lesson and then we'll review for our final.